The graph of function fx equals to negative 2x cubed plus ax squared plus bx plus c is sketched below. The following properties of f are given below. Point A, 1 and 0 is a stationary point. Point B, 4 and 0 is an x-intercept. Point P is the point of inflection. Point C is the turning point. Point D is the y-intercept.
Yes, thank you so much, Jose. So once again, they say the graph of the function f of x, which is defined as negative 2x cubed plus ax squared plus bx plus c, is sketched below. We are not given the entire equation of the function. We are only given the coefficient of x cubed, which we know that determines the shape. If it is negative, then the function will look like this. But if it's positive, the function will look like that. Okay. The following properties of the function are given. They say the point A is the stationary point. The point B is an x-intercept. P is a point of inflection. C is a stationary point as well, because we know that a turning point is a stationary point. And then D is the y-intercept of the function. And this is our nice and beautiful function, which we can see here. That's fine. Now, the first question says, please show that A is 12, B is negative 18, and C is positive 8. That's what the question is saying. In simpler terms, the question is saying, find the equation of this cubic function. That's what they're saying. Now, we know that there's actually three cases for finding the equation of a cubic function, but the relevant one in this case depends on what is it we are given. And in this case, we are actually given three x-intercepts. That's what is being given to us here. I know that one of the x-intercepts is actually a turning point, but nevertheless, it's an x-intercept. Yeah, the turning point here is still an x-intercept. So we are given three x-intercepts. Why am I saying three? Well, that's because we know from a parabolic function that if we have x minus 2, which is all squared, we know that that's actually when the turning point is at 2. So it's still an x-intercept, but then it's repeated twice. That's why I'm saying we have two of them, because this bracket is x minus 2 as well. So I'm just going to count it twice. So we have three x-intercepts here, but we don't have a point that is lying on the function. No, it's not given to us. Okay? So since we don't have one other point, but this is the equation we are going to use. We say in order to find the equation of this cubic function, we know that we are actually going to take A and multiply this by x minus x1, multiply this by x minus x2, multiply this by x minus x3. This is the form that we use every time we want to find the equation of a cubic function such that we are given three x-intercepts and one other point that is lying on the function. The significance of that one other point is to help us to be able to get the value of A. But since we know A in this case, We don't need that one other point. So our a is normally the coefficient of x cubed. That's how it is. In the general equation of a cubic function, it's ax cubed plus bx squared plus cx plus d. This is how it is in general. Just that since it's given to us, they decided to call B A and to call C B and to call, what am I saying? Yeah, but that's what I'm trying to say. They just switch them around because we already know the coefficient of x cubed. That's not a problem. So we know that our coefficient of x cubed is -2. So you're going to take it and put it in the place of a. Then you say x minus x1. Well, in this case, we focus on the first x-intercept. And we can see that it's repeated twice, as I told you, because it is at the turning point. So x minus x1, x minus x2 is the same thing, but you take it once and you repeat it twice. Then next you say x minus x4. Then you come back and you expand your square using the FOIL method. So x by x you get x squared, x by 1, 1 by x, adding the like terms, -1 squared. Well, this is what you get. Then we still have our -2 here. But here we are dealing with a product of a binomial with a trinomial. So we need to distribute each term in the binomial. Well, that's how it works. So then, what is it we get? Well, x by x squared, x cubed, x by 2x, 2x squared, x by 1, x. -4 by x squared, -4x squared, -4 by -2, well, that's +8, and -4 by 1, that's just -4. Then you collect your like terms, -2 minus 4, that's -6, and 1x plus 8x, that is 9x. And of course, you still have your -4 here. Then the last step is to distribute the -2. Well, in which case you get something that looks like this one. Right. Then now you can make a conclusion and say, therefore, A will be 12, B -18, and C +8. They were just asking you to find the equation of this cubic function, and that was just it. Now, this is what they say. They say, Kusal, he states that a tangent to the curve f can be drawn through the points C and D. Then our task here is to validate this statement using an appropriate calculation, and this is for 3 marks. Let's go and look at the graph. So what the gentleman is saying here is, we know that a tangent line is going to touch this graph at that point, at a turning point, that is to say. But now he actually claims that this tangent can be extended. And when it does, it's going to pass through the point D as well. What is he saying in simpler terms? We know that at the turning point, that's where the tangent line is going to be horizontal. So in other words, what this gentleman is saying is the straight line CD is going to be a turning point. That's what he's saying in simpler terms. Wait a minute, what am I saying? No, I'm lying to you. Sorry. Seems like I'm sleeping. Okay, I wanted to say what the gentleman is saying is the line CD is a horizontal line. That's what I wanted to say. In other words, our task is to show that the y value at D is equal to the y value at C. Then a tangent line can be drawn through those 2 points. Yes, we know that a tangent at the point C is going to be horizontal. We know that. Our duty is to show that the line CD is a horizontal line. Now the question is, how do we show that CD is a horizontal line? That's a good question. That's a very, very good question. Well, what we can do here is to find the coordinates of the point C. That's what we can do. And then find the equation of CD, which is also the equation of the tangent line to the curve at the point C. Yeah, I know as I explain it, it seems like a lot of work. And as a matter of fact, it is a lot of work. I'm rather surprised it's awarded 3 marks. Maybe there's a shorter way of doing it. But since I couldn't figure it out, then I'll just show you the longer approach. Now, let's go ahead and find the derivative of the function. We know that the function itself, I'm just going to write the equation on top here. F of x is negative 2x cubed. And then we say, plus 12x squared. And then we say minus 18x plus 8. That's the original function. Why do we need to differentiate this? That's because we are looking for the coordinates of the point C, which is a turning point. All right, so let's go. We say the derivative here is going to be negative 6x squared, 24x minus 18. Then we equate the derivative to 0. And if I were to divide throughout by negative 6, 24 divided by negative 6 will just be negative 4. And 18 divided by negative 6 will be negative 3. I hope you get the reason why I want to do this. Well, that's because I don't really like using the quadratic formula, so I wanted to simplify my quadratic equation so that I can easily factorize it. Well, both of these factors have got to be negative. It should have been positive 3 when we divide by negative 18. Sorry about that. So then, the coordinates of the turning point will just be 1 and 3. And of course, at C, it's not going to be 1. It's going to be 3. Then next, we need to find the y value when x is 3. Of course, the y value on the original function, because we said we want to find the coordinates of the point C. So I'm not going to show that step, but please do show it. I'll just go into my calculator and substitute a 3 in the original equation. And when I do, I get a y value of 8, which means that the coordinates of the point C is just going to be, or rather, are just going to be 3 and 8. I think this is actually enough for you to make a conclusion. Now, what are you going to say if you must make a conclusion? Well, let's think about it. I don't think you should find the equation of a tangent. No, you don't. You don't really have to do that. No, no, no. As I think about it now, I realize that you don't have to. But now we can see that the y values on this, the y values are the same. That's what we have seen. The coordinates of the point D are 0 and 8, and the coordinates of the point C are 3 and 8. So I think we are ready to reason with them. Now also tell them that you are aware that the coordinates of the point D are 0 and 8. Where do they come from? Because 8 is the y-intercept on your function. Well, I think here you can give them a little bit of an essay. How? Tell them that, since the tangent to the curve at C, and also tell them that you are aware that C is a stationary point. Yes, since the tangent to the curve at C, which is a stationary point, is horizontal, and furthermore, the line CD is horizontal as well. Yes, since a tangent is a horizontal line, and the line CD is a horizontal line as well, then what? Then when you make your then, we need to remember what the person was saying. Yes, then the tangent to the function can be drawn through the points C and D. Yes, it can be drawn through the points C and D, because we have now shown that CD is just a horizontal line. So yes, I strongly believe if you say this, it should be fine. I don't think you should really work a lot here. There's really no need to find the equation of a tangent, because anyway, the equation of a tangent will be y equals 8, because the gradient is 0. So if you just convince them this, then yeah, no, that's awesome. That's awesome. Yes. You can also add, when you're saying CD is a horizontal line, you can also add that the y value at C is equal to the y value at D. You can also add this in brackets when you say CD is a horizontal line, to really convince them beyond reasonable doubt. However, if maybe you found that the two y values are not the same, the y value at the turning point was not the same as the y value at D, then how would the difference be in that case? Well, it would then mean that C, this is how it would be. Let's say you found different y values. I think it's rather important to show you that one as well. Well, let's say maybe the y value at D was somewhere here. Then was it going to be a tangent through C? Well, it's possible it won't be a tangent. It's possible it's going to cut it here as well as somewhere else. And even if this line was lower than D, then yes, we can see that it's really going to cut at 2 points here as well as there. Well, of course, I'm not using rulers here. I don't have them on this PDF, but if you were to sketch this and use rulers to do those straight lines, you'll see that they're now going to cut the curve at 2 points. So, no, we can't draw a tangent through, through those if it's not a horizontal line. So this is what the next question is asking from us. They say the points A, P, and B are joined in order to form triangle APB. All right. Then the question says, please calculate the area of triangle APB. That's what the question is asking from us. And this is a 4-mark question. So let's go and see this triangle APB. Well, this is the point A, and it's joined to the point P. And this in turn is joined to the point B. And this is our nice triangle APB. We need to find the area of this. That's fine. But now I know you're not using a calculator. No, what am I saying? I don't know what is it I want to say. This angle, it is not clear whether it's 90 degrees or not. And since we are not given that it's 90, we must assume that it's not 90. All right? Very important. In other words, we treat it as if it's any angle other than 90 degrees. So then how can we get the area of this triangle? Well, that's easy. We are just going to cut this triangle into two. So we divide it into two halves by drawing a vertical line. And this vertical line is perpendicular to the x-axis, which means that I have now generated two triangles here, both of which are right-angled triangles. That's what we are saying. However, I want you to realize something. What is that? If you look at the point P, they told us in the statement that this is a point of inflection. And we need to know the coordinates of the point P. We really do, especially the y value at the point P. Why do we need to know the y value at the point P? Easy. That's because the y value at P is actually giving us the height of each triangle here. So if we know that height, then we can find the area of this triangle. We can also find the area of this triangle as well. So now we have identified how to find the height. That's fine. What about finding the length of each triangle? Well, in order to find the length, you need to know the x value at P. So in other words, we need to know the x coordinate of the inflection point. So that if we know that x value, then we know the distance from here to there. We also know the distance from here to there as well. So that's the first thing we need to do here. Find the coordinates of the point of inflection. You can go ahead and find the second derivative and equate the second derivative to 0 and then solve for x and get the x value. But I'm just going to use the simplest way out. What is that? We now know the coordinates of the point C. We said they are 3 and 8. And if you want to get the x-coordinate of the point of inflection, we know that the point of inflection is actually halfway through your two turning points. In simpler terms, I'm saying the point of inflection is the midpoint. That's what I'm saying. It's the midpoint of your two turning points. So when we want to get the x value of this turning point is 1. The x value of that turning point is 3. So I need to add the two turning points together. And 4 divided by 2 is just going to give us 2. What about the y value? It's the same thing. It's the midpoint of the turning points. So the y value of the first turning point is 0. And the y value of the second turning point is 8. And of course, dividing this by that, we get a 4. So this means the coordinates of the point P are 2 and 4. Please show those workings. Okay, fine. Now we know the x value here is 2, which means the length of this red triangle will be 1 unit. It's from 1 to 2. And the length of the green triangle will be 2 units. It's from 2 to 4. So then, the area of triangle APB, we divide it into 2 triangles as we said. Going to the first triangle, you say, the base here is 1 as we said, and the height is going to be 4 because we said the height is the y value at P, and we found it. Then we take the area of this first triangle, we times it by the area of the second triangle, where the length of its base is 2, and the height of it is still going to be 4. So then, half of 4 is 2, and half of 8 is 4. So 2 plus 4 will simply give us 6 square units. Well, that's how we found the area of APB. So let's move on to the next one. Then here they say for which values of x is the function concave down. Where is this function facing down? Okay. In order to answer questions concerned with the concavity of a function, we need to go to the point of inflection. Because we know that at the point of inflection, that's where concavity changes. That is what we know. So we now know the point of inflection here. We said it's going to be, and this thing is refusing to erase now. I wonder what did I do to it. I'm sorry guys, it's not communicating. Okay, nevertheless, we said the point of inflection is at an x value of 2. That's where concavity is changing. And if we look at this function, we see that from negative infinity all the way to 2, the function is facing up, or concave up if you like. But from 2 all the way to infinity, the function is now facing down. For which values of x is the function concave down? For all values of x that are strictly greater than 2. That's where the function is concave down. But if they wanted to know where is the function concave up, well, it's concave up for all values of x that are less than 2. And of course, if you like, you can say it's for all values of x from 2 all the way to infinity. Yes, those are the two notations that you can use. But remember, you must not include your 2 as you do with increase or decrease. No, because at exactly 2, concavity is changing. Super important. We want where it is strictly concave down. The next they say, write down the values of x for which the function is strictly increasing. And this is important because when the question says for which values of x is the function increasing, then you can also include the turning point if you like. For instance, I'm sorry guys, I can't erase. I think maybe I should close the document and open it again. It's working now. Yes, I was saying, we know that the function is increasing from 1 all the way to 3. But if the question just says, for which values of x is the function increasing, you can answer it in one of two ways, depending on what you want. You can say, from 1 all the way to 3, or you can say, from 1 all the way to 3, excluding your turning points. That's when they say increasing. But when they say strictly increasing, then you must exclude the turning points and only take this part. That's the only difference, and it's terribly important. Please take note of that. Then the last question here says, write down the coordinates of the turning points of h if it is given that h is a function of f that has been shifted 3 units down. Well, it's a function that has undergone a vertical shift. Vertical shift, which means it's only the y values that have changed. The x values will still be the same. What were the x values again? The first x value was 1. And the second x value is, yes, so you can also write it in interval notation. Oh, it's actually Ubudle's case. The next one is 3. So these are the two turning points like that. But now for the first one, which is at B, I think I can't remember now. At A, the y value was 0. But when we shift it down, it's -3. The one where the y value was 8, when we shift it down, is simply going to be 5. The y values are just shifted 3 units down. And that will be the coordinates of the turning points of h of x. Yes, understanding the transformation was the key.